Hello everyone. Thank you for joining us here this evening for Starbound, Space in Songs and Science. I'll be launching my new EP of space songs, so we'll play some songs from that, and then in the middle we'll speak to space engineer Gilles Bailet, lecturer in space technology, about his views on some of the topics of the songs, and also his work more in general, building things that go into space, which I think is really cool. Yes. So. Start off with one I wrote about billionaires going into space, because all the problems have been solved on Earth. We are curiously small. I am in the clay, in the soles of his shoes. He is miraculously tall. His pockets are so deep, they fit in people, important people. He dreams a young boy's dream, points up to the stars. He says we can always start again. You know the future lies between the moon and Mars. He'll build a rocket to take us there. Oceans crawl out from their shores. I outrun the storm, but for how long? Runways keep his spirits high. He's got the cash to buy a lonely mountain, a private mountain. He dreams a young boy's dream, points up to the stars. He says we can always start again. You know the future lies between the moon and Mars. He'll build a rocket to take us there. But when we get there, could it ever be enough? Perhaps all he needed was a little bit more love. He dreams a young boy's dream, points up to the stars. He says we can always start again. You know the future lies between the moon and Mars. He'll build a rocket to take us there. He'll build a rocket to take us there. That's hopefully the nervous energy out of the way, because the next one is a bit quieter. Yeah, we tend to talk about astronauts, but this next song I've named Cosmonaut after the Russian name for people who go into space. Not because I'm necessarily for the Russians or anything, but I just thought it's quite mysterious, and I was reading a book about the Soviet space program, and it actually starting off quite well earlier than the Americans. It formed into this song, but actually the song is a metaphor.
They keep him company as he charts the Milky Way. The starlight that he sees is centuries old. He dreams of other worlds. Cosmonaut, cities shine brightly on the dark side of the earth, but he is much lighter and quickly passes by. From the ground I see him shooting through the sky. I'm dreaming of his world. Cosmonaut, cosmonaut,
On keys with me here is Jonni Slater. And you're still learning all those chords. Yes. So the next song is a song about a satellite. It's called the European Remote Sensing Satellite number 2, or ERS2. When I wrote this song, it was just coming back through the atmosphere and basically burning up. But it had been sent into space in like 1995, and it was one of the satellites monitoring floods and the size of ice on the Earth. So it gave us information about climate change and how quickly that was going. And I identified with the satellite and wrote this song. I put it like on this platform for songwriters, and someone thought it was a metaphor for a long marriage. But no, I actually just wrote it about the satellite. Yeah.
In the blink of an eye, 30 years go by. You are always in my thoughts, too far to die. sentinel, my silent vigil for you. My purpose, your sentinel in perfect solitude. Now it's time to go home. We did it all just for you, and I have always known I would burn for you. Like you want me to fall into the atmosphere. My purpose, your sentinel, my silent vigil for you. My purpose, your sentinel in perfect solitude.
Thank you. So, for this next bit, I would like to invite Dr. Gilles Bailet to speak with me.
Thank you very much. Lovely songs. I have a really strong accent, so let me know if you have any issues with it.
Yes. So, I prepared some questions. First of all, can you introduce yourself and what you do at the University of Glasgow?
Okay, so I'm Dr. Gilles Bailet. I'm a lecturer here at the University of Glasgow, so I have a big responsibility for teaching young students, but I also do my own research where we are trying to do in-space manufacturing. So basically, you are manufacturing things directly in space using 3D printing. So you can imagine giant antennas, giant telescopes, and other fun things like that.
Okay, we'll get back to that. So my first song was quite critical about space exploration at this point, saying we should solve our problems on Earth first. But I know you think differently about this. So why is space important?
So there's different problems nested in each other. So space is it's really useful for society for many reasons. You talked about monitoring climate change. That's really important. Every time you take an airplane to go on a holidays, for example, we need satellite images for the weather predictions. You can actually also predict catastrophes like hurricanes and other things like that. But there is way more than that we don't really see directly, like food security, for example. If you're able to have food on your plates, it's because from space you're able to monitor the health of plants on Earth, and you're able to predict when you need to water the plants, when you need to put pesticides, and also how much food you will get 1 year in advance. And you get many other things, like dialysis machine, for example, which is a big machine at the hospital that filtrates the blood. This was invented for the space exploration, right, to recycle urine of astronauts. So I think space is really important, but regarding your song, I think it's a bigger question. I don't think it's a good idea to send rich people to space.
That was going to be my next question.
But that's exactly like against the aspect of sustainability, right? So people think that if you send rich people in space, it will bring money to the industry, that then you will be able to funnel in new innovations and solve the problems on the line. But I think we have to just rethink the way we engage people with space, to explain to them better what space brings to people, but also listen to what people want, right? Because it's not because scientists think that they should do something that is good for the planet, that we necessarily need to do it. And so I'm spending myself a lot of time talking to people which don't like space at all, and try to actually come up with what we should do with space and how we can better help society, and not just be big space nerds in our labs and having fun launching stuff in space.
Okay. So late last year, you yourself went on a zero gravity flight. Can you explain what that is? Because I hear it's called the vomit comet.
Yes. So that's a big plane, but that's some kind of roller coaster in the air, right, while flying. And so every time it's at the top of a roller coaster, you're going to be floating like in microgravity, duplicating the conditions of space. And when it's at the bottom, if you pull down, you have 2 times the gravity, right? And so you're able to test some technologies like we did to 3D print things directly in space when you are at the top of the roller coaster in microgravity. But also it's called a vomit comet because when you're at the bottom, you feel your organs, everything in your body be pulled down really, really hard, and normally people puke. So they actually, the really good thing is they give you a shot of medicines in your arm, which actually have the same side effects as when you are drunk, right? So you feel really happy, you feel a bit dizzy, a bit sleepy, but you don't puke, which is the most important part. And so you're able to do the science for about 2 hours of flight. You get 30 microgravity parabola, that we call, which are about 20 seconds each. And so you get 20 seconds times 30 to do all the science you need.
Cool, yeah. So you did not get ill because you had these shots?
Shots, yeah. I was also really happy because my big smile in the videos.
Okay, so can you tell us a bit more about what you were testing on board?
Yes, so we want to 3D print things that are in space. So basically we are using plastic, we are melting it to 3D print to create antennas, solar panels, radiators, and a bunch of other parts of spacecraft that we need. But we want to do that safely. So we don't just want to send things in space and that maybe we didn't do it correctly, it's going to break up, create space debris that might kill another satellite. So we need to extensively test that to make sure it's going to be 100% safe and work 100% as we want it. And so we had a wee box that we put bolted on the aircraft that was testing this technology in the microgravity, the same as we're going to have in space.
Yeah, so that like little plastic pellets in that?
Exactly, so we are using a different technology to do this 3D printing, which is using tiny pellets that we are then melting, but we need to move these pellets around inside the spacecraft to make them do what we want them to do.
Yeah, because on Earth they will just go down because of gravity, but in space they will just be floating around in a compartment, and you have to get them to where you're...
It's really, really hard to control things in space. Even yourself, your own body, you need to be strapped down to the aircraft, otherwise you fly off somewhere else. But don't worry, there's a bunch of people for your safety in the aircraft, but if you start to float around, they're going to grab you, and then they're going to put you in the corner because you didn't strap yourself well.
What are your plans for this technology? Like, how far along is the technology?
Yes, so we demonstrated that correctly. We had also another project funded by the taxpayer money, so thank you very much, through the UK Space Agency, where we wanted to make sure that the plastic we're going to use to fabricate this in space will react correctly to the space environment. So in a building not really far from it, we have a really big metal box where we are creating ultra-high vacuum. So it's like there's almost no air at all inside it. And we are cooling down the samples that we want to test to really, really low temperatures, so minus 150 degrees to plus 250 degrees. And to make sure that whatever we are putting in space will not again break up in millions of space debris, and it's going to be safe for everybody, to make sure that we can maximize the use of technology for the benefit of society on Earth.
Okay, so my last question was actually going to be, what is your vision for the future of space engineering? But I guess that's probably almost it.
So I think there's a good analogy. So the crazy thing that since we started sending stuff in space like more than 60 years ago, all the space engineers like myself, when I was still working in industry, we all shed sweat and tears trying to optimize the spacecraft to be able to resist the rocket launch. And it's a bit crazy when you think about it. You need to package and to optimize every bolt, every screws that you are putting inside the rocket because it needs to fit within the fairing, the top of the rockets, and then it needs to withstand and survive the crazy acceleration and vibration of the rockets. And then, so this is only 10 minutes, so you are optimizing your spacecraft for first 10 minutes of the mission for a spacecraft that will spend 5, 10, 30 years as your friend, the spacecraft. they spend 30 years in space. Because if you are following the physics equation, the optimal shape of a spacecraft is not a fridge like you've seen all the spacecraft in your life. It's actually a really big 2D surface. Because then you are maximizing the surface for antenna, for solar panels, and other things like that.
Sorry, what is the optimal?
A big 2D surface, so like
Oh,
a
2D
piece of
surface.
paper, something really flat but really big. That's optimal. So our vision, so what we are doing with the technology we developed, we're going to create a spin-out, which is some kind of a startup from the university, where we're going to 3D print entire spacecraft directly in space, and the idea is to use rockets less and less. I don't like Elon Musk at all. I think what he's doing is really dangerous, building bigger and bigger rockets to put more and more trash in space. What we want to do down the line is only to send in space the really valuable things. That can be a really fancy telescope, and you're going to build the rest around it, or it can be even a human, right? And you're going to 3D print bigger things that are in space. And what we are really working on at the university, and what Scotland is actually really pushing, is sustainability in space, and down the line to have a circular economy, right? To try to other things being recycled and reused again and again in space. So we don't use rockets that much anymore, and the tiny launchers that we are building in Cosmonaut, only 20 minutes away, will be enough for all the space missions you want.
Okay, great. Do you have any questions for Gilles?
Yes?
So you mentioned that the optimal shape would be just a big old bang, just a
Yes.
2D sort of. Is that for a space station or for a space
For-
shuttle?
For everything, all the spacecraft.
So how would it get into space in the first place? Where would you?
So you will just bring in space raw materials, so pellets, feedstock, anything you want, and then you will 3D print, manufacture things, assemble it directly in space to look like a flat surface. So it's really changing entirely the way we are doing things,
Okay.
right? So it's like you are sending in space paper and ink, and you are printing your reports in space. That's the idea, right? You are assembling things with your 3D printer in space.
Yeah. So it would have a different shape when you're launching it, and then it would like reassemble itself or manufacture itself into that sort of 2D shape.
Exactly, and down the line, you will not even need a rocket anymore, because the material will already be there, and you will show up what already exists, space debris or all antenna, for example, to make a new one exactly the way you want it. And so you can imagine that if you send today 1 kilogram of plastic, it might be used over and over again for like a century, right? And you will have saved maybe a dozen of rockets.
More questions?
Is this technology all over? Is Scotland at the forefront of this, or is it
Yes,
something that
so-
they're all doing?
But that's a really good thing. So everybody is interested about that, and you get in the US, they have like hundreds of millions into it. I don't have hundreds of millions by far. But what they're trying to do is to have some kind of a monopoly by trying to patent everything that exists, right? But the big issue is that those patents are not really good, so they're not valid in UK or the rest of Europe, but they are valid in space because the way the US patent law is written. So when I arrived 5 years ago, I was tasked with actually inventing a new way of doing that. And thanks to these flights, we were able to demonstrate a new way of doing this 3D printing. And so actually Scotland now is actually at the forefront of that. We have our own way of doing 3D printing in space. And we did that with a really tiny budget compared to the US. And we are really well aligned and really well supported by the rest of Scotland.
I guess that's also why you're here, because you were working in France before, right?
Yeah, I worked all over, but I worked also in Paris just before this job. But I prefer Scotland by far, right? I will not come back. I will not come back to Paris. But yeah, so I do recommend stay here, live in Scotland, bring your friends. It's really fun.
Okay.
Can I ask a question?
Yeah.
So, see, you were saying that what can happen in space can also translate to learning and sort of innovation down here. Is the things that you're talking about, like recycling and reusing, are you guys also working in tandem with like other departments or other agencies to see how that could translate down here? You know, so we're not so wasteful and
Yeah,
use more.
that's a really good question. Something which is really dear to me. It's called downstream applications. And we are really trying to push that. So that's really hard. Like that's myself in my lab trying to do all of that. So there's not enough of me. So send your friends that want to do a PhD with me. But we are really trying to push that. What is really cool and why we have so much innovations coming from space is because it's a really extreme environment. It's the worst place to be. My favorite planet is Earth, because I'm the only one which is a good one, right? So as soon as you go to explore the moon, for example, there's like a lot of things to do on the moon. You will need to be way more efficient in how you use your resources, how you recycle, because it's just way too expensive to go there. Whatever the rocket you are using is way too expensive to send like even 1 kilogram of anything there. So there's a lot of teams all over the world which are working, for example, in better ways to filtrate water, to make more things out of waste, out of just like even bodily fluids and stuff like that. We can make way more things out of it. I'm working with a researcher here in how can we 3D print batteries on the moon, and part of that is the human key. It's part of the components of how you actually 3D print a battery. Right? So we are really working toward that, trying to push for it. And it's where I think we need to do better communication, because the UK Space Agency, the way they try to show you that space is important is by showing you shiny rockets or like astronauts that went to Oxford, and there's no way we relate to that, right? I don't even relate to that, and I'm in the space industry. So we just need to show more things. So for example, I'm also working with a School of Philosophy to try to see how we can rebuild trust with the public, and how what we do, we break the echo chamber and we actually do things that matter for you guys.
Yeah, because it's almost like if it's more exciting to go and recycle your plastic if you're making a contribution to space.
So you're making,
yeah. Do you know what I mean? That would make it even more exciting. For
so if you want to be excited about paying your taxes, every time you pay your taxes, there's a tiny bit of my spacecraft going up in space.
Cool. We have time for a final question, if anyone has it.
Have you any further prediction where the first prison planet's going to be?
Prison planet, I think I will put people in a space station. It's way more dire than the planets. Right? Because the planet, you can always dig your way inside to get a nice shelter and make yourself cozy. Space station, you're just stuck there with what there is.
Excellent. Could you use your 3D printer to create a kind of panopticon form?
You can do like anything you want with 3D printers. That's the magic of it. Yeah.
Okay, thanks, Callum. Thank you so much. So I wrote another song about man-made objects that went into space. This one is about the Voyagers. They were launched in 1977 by NASA. And in that year, the planets in our solar system were aligned, so they thought it was a good time to go and take some photos of Jupiter, Saturn. Yeah, so that's when they launched, and they're still out there, but they're no longer near. They're outside of what they call our heliosphere. They're in interstellar space, and they just keep going because they've got momentum and there's nothing to stop them. So they'll probably keep going for a long time after we're gone. So this is Voyagers. You look at the stars and you ask yourself if you're alone. Out of your dreams you build me up, send me with hope. We're sister and I fly as planets alive. Jupiter calls, fearless for you.
and I know we'll soon be out of reach. Then it's just me and my sister. We are the first to go this far. We are on course towards another star. We are the first to go this far. Don't be sad, you've made us what we are, Voyagers.
Thanks very much. So on board these Voyagers, still going, they've got golden records, like a vinyl, thin layer of gold, with on it data about us. So there's sounds and there's images, and it's flying in space for maybe an alien to find in some distant future when we all no longer exist. Or, yeah, like a time capsule. How mostly the Americans, but there were international contributions, how they like to think of themselves at that point. So, this is Golden Disc.
Hear our heartbeat, hear our footsteps, rolling thunder, kissing lips, our human words, the songs of wills engraved in a golden disc. Behold our bodies and DNA, our solar system, seashells and fish, the miracle of birth, brainwaves buried on a golden disc. For our inventions and our for once we are more than the sum of our parts. We are ancient, we're lost in time. This greeting is our final wish, forever in motion between the stars. All that's left is a golden disc.
For listening and being here tonight. If you like the songs, you can take them home. So this is my new EP that I just made. The masters came back fresh this morning. Yeah, so it's 6 songs and I've made download cards. And if you want a CD, I can send it later. Yeah, and there are lots of musicians playing on this record. So Jonni who you've been hearing, but also David, who's just sitting there nodding to the beat. But he plays bass on some of the tracks, so yeah. So officially this is the last song, but if you really like it, we might have something else that's still on theme. So I grew up watching a lot of Star Trek. I'm not sure if any of you did.
I like Star Trek,
Yes.
Star Wars as well.
So this is a little love song for Star Trek, basically. Or Mr. Spock, however you want to see it. Don't worry, it's a long time ago.
We hear the call of distant suns. We've always known we're not alone. Our hearts are sure we plot our course in silver machines to touch this dream. It's real if you choose to believe in it. Starbound, we are starbound. Faster than light, time passes by. For we are starbound. We have to find what lies behind the movements we see of stars and galaxies. Your energy, it draws me in, feel the gravity between you and me. I watch you from under my eyelashes. Starbound, we are starbound. Faster than light, time passes by. We are starbound, starbound. Faster than light, time passes by. For we are So this is a song I wrote with my band, the prog rock band Long Earth. But this is just the first half of it because that goes on for another 6 or 7 minutes. Because I was writing this EP with all space songs, so I was really just thinking about these things. So for the band, I wrote this about Galileo. Yeah, so at his time, telescopes, or spyglasses as they were known, they had been invented, but they were not so powerful yet. But he improved the design with like a factor of 8, and he pointed it at the moon and at the solar system and the Milky Way, and all of a sudden he could see way more, like the craters, the mountains on the moon, the rings around Saturn, the Milky Way was not just a mist, what people thought, it was actually thousands of stars. So this is about his discovery of that and a bit of his resistance against the church, because of course at that point everything was supposed to revolve around the Earth instead of the sun. Can't argue with science.
You find me shrouded in the dark. My spyglass aimed towards the sky. I pull you closer than anyone before. What I see I won't deny. Show your face to me, beautiful beyond belief, and I will never be the same. I'll be your messenger, observer of your universe, infinitely amazed. For princes wander around Jupiter. I see mountains on the moon. The Milky Way is made of a swirl of stars. We dance in circles around you. Show your face to me, beautiful beyond belief, and I will never be the same. I am your messenger, observer of your universe, infinitely amazed. With eyes closed, they still know that the heaven